Here's a matrix 1, 2, 3, A, B, and C. It has 6 elements. How many rows does this matrix have? Well, if we count, we have one row and another one. This is row 1, this is row 2. So we have 2 rows. How many columns do we have? Well, we have this first column, second column, and third column. We have 3 columns. So we have 2 rows and 3 columns. What's the order for this matrix? So for the order, we take the rows and then we take the column. So the order is 2 by 3. That's the order for this matrix. Now the question is, can we rearrange the elements? Having the same number of elements, can we have a different order? Think about it. Okay. If I flatten this out, I'll get 1, 2, 3, A, B, and C all written in the same line. This is also a matrix. How many rows and columns does this matrix have? So it has only one row. This is the only row that is there in this matrix. So one row. How many columns do we have? Well, this element 1 is in the first column. The first column only has one element, but it's still a column. So 1, 2, 3, 4, 5, and 6. This matrix has 6 columns. So what's the order? The order is 1 by 6. One row and 6 columns. Are there more such combinations? Can you rearrange these elements in different matrices having different orders? Pause the video, think about it. Okay, let's do this together. If you flip this, you can get 1, 2, 3, A, B, and C written in this order. So how many rows, how many columns? We have 1, 2, 3, 3 rows, and then 1 and 2, 2 columns. So this is different than this one. This matrix has 2 rows and 3 columns, whereas this matrix has 3 rows and 2 columns. Both of them are different. The order is 3 by 2. And we can do the same with this one as well. We can have 1, 2, 3, A, B, and C all written in the same column. So how many rows? We have 1, 2, 3, 4, 5, and 6. 6 rows and then 1 column. So what's the order? The order is 6 by 1. Are there more such combinations? Well, no. These are the only 4 combinations that we can have if the number of elements are fixed, if we have 6 elements. So for 6 elements, we have these orders. Possible orders are 2 by 3, 1 by 6, 3 by 2, and 6 by 1. Now the question is, how do we figure this out for different numbers of elements? For n elements, how many possibilities do we have? Let's figure that out. How many orders, how many possible orders would we have for 8 elements, or 24, or 18, or 5, or 13? Pause the video, try figuring the answer out for all 5 of them. Okay, let's do this together. Well, one way of arranging the elements could be, we can have all of them in the same row. We can have one row and 8 columns. That's one possible order. We can have 2 rows and each row can have 4 elements. So this makes 2 by 4, 2 rows and 4 columns. And we can flip these around. We can have 4 rows and 2 columns, or we can have 8 rows and 1 column. So the possible orders are 1 by 8, 2 by 4, 4 by 2, and 8 by 1. Let's look at the next one. 24. It's a big number. Let's count the number of possible orders. We can have 1 row and 24 columns. So 1 by 24. We can have 2 rows and 12 columns. So 2 by 12. We can have 3 rows and 8 columns. We can have 4 rows and 6 columns. And we can flip them around. We can have 6 rows and 4 columns, 8 rows and 3 columns, 12 rows and 2 columns, and finally we can have 24 rows and only 1 column, all of them stacked in 1 column. So how many possible orders? 1, 2, 3, 4, 5, 6, 7, and 8 possible orders. Let's look at the next one, 18. We have 1 by 18, 1 row and 18 columns. We have 2 by 9. We can have 3 by 6. It's not divisible by 4. We can have 6 by 3. We can flip this. And 9 by 2. And finally 18 by 1. So for 18 elements, we have 6 different possible orders. What about 5 and 13? How do you split 5 in rows and columns? Well, we can't. 5 is a prime number. Either we'll have all the elements in one row or we'll have all the elements in one column. either the order will be 1 by 5 or 5 by 1. The same is the case for 13. Either we'll have all elements in one row, that's 1 by 13, or all elements in one column, that's 13 by 1. So for these two, the number of possible orders is 2. So what's the pattern here? For 8 elements, we have 1, 2, 3, and 4. 4 number of possible orders? Well, 8 has 4 factors. 1, 2, 4, and 8. And each of these factors could be the number of rows that we have. And if we divide 8 by that number, we'll get the number of columns. So for each factor, we have a specific combination. We have a specific order. 8 has 4 factors, so we have 4 possible orders. 24 has 8 factors. 1, 2, 3, 4, 6, 8, 12, and 24, which is what gives us 8 different possible orders. 18 has 6 factors, which means we have 6 possible orders. 5 and 13 are prime. The number of factors for 5 is 2, 1 and the number itself, that's 5. Same is the case for 13, 1 and the number itself. So for these two, we only have 2 factors each, which means we only have 2 possible combinations, 2 possible orders. And we can generalize this. If we have n elements, the total number of possible orders are equal to the total number of factors of n. And at first, it seems like the answer is always even. We have 2, 2, 6, 8, and 4. But look at these number of elements. For one element, what's the total number of possible orders? What about 4 or 9 or 16? Pause the video, think about it. Okay. For one element, we only have one way of making the matrix. We'll have one row and one column. That's 1 by 1. For 4, we have these ways. We can have 1 by 4. We can have 2 by 2. And we can have 4 by 1. Notice that we have an odd number of possibilities. For 9, we have 1 by 9. We have 3 by 3. And we have 9 by 1. Again, odd number. For 16, we have 1 by 16. We have 2 by 8. We have 4 by 4. And then these two can be flipped. We can have 8 by 2 and 16 by 1. So 1, 2, 3, 4, and 5. Here as well, we have an odd number of possibilities. So 1 has 1 factor. 4 has 3 factors. 1, 2, and 4. 9 also has 3 factors. 1, 3, and 9. 16 has 5 factors. 1, 2, 4, 8, and 16. So if we have perfect squares, 1, 4, 9, 16, and so on, we'll have odd number of factors, which means we'll have odd number of possibilities. So let's write this down. Perfect squares have odd number of factors, which means we'll have odd number of possibilities. Now, one of these possibilities, 1 by 1, here we have 2 by 2, and here we have 3 by 3, here we have 4 by 4. These give us square matrices, and we'll talk about square matrices in a different video. These matrices have equal number of rows and columns. All right. Now we can apply similar counting methods to figure out total number of matrices as well. Here's a problem. Find the number of all possible matrices of order 3 by 3 with each entry 0 or 1. Here we fix the order, that's 3 by 3, and the entries can change. They can either be 0 or they can be 1. And we have to find the total number of possible matrices. Pause the video, try this out. Okay, so here's our 3 by 3 matrix. We don't know each of these elements, but they could be zeros or ones and nothing else. Here are a few examples. Okay, but how do you figure out the total number of possible matrices? Let's think about it. Each of these could be 0 or 1, which means if you have to just look at one of the element, let's look at this first element, this could be 0 or 1. So we have 2 options for this. Similarly, we have 2 options for this, 2 options for this, 2 options for this, and so on. So each of these could be 0 or 1, which means each of these has 2 options to be filled. So how many decisions do we have to make? We have to make 9 decisions. And for each decision, we have 2 options. So using P and C, we can say that our total number of options, our total number of possibilities is 2 to the power 9, 2 multiplied by itself 9 times, that many number of options. And 2 to the power 9, that's 512 possible matrices.